Okay, maybe see it a little bit easier this way. Okay, so I'm going to decrease on time. Okay, now what I'm going to do is increase on time. This is increasing on time. Increasing. Now I'm turning the dial in one direction. See, amplitude is shrinking, and then the amplitude starts to grow again. Amplitude is growing. Amplitude is growing. Amplitude is growing. Amplitude is growing. And then amplitude is shrinking right there. So you see this little region right there, and then it starts to grow again. Okay, see that? A little swing right there. There's a little non-linear zone right there. And so as I'm decreasing, okay, this is decreased on time, I'm increasing on time, amplitude is growing, and then amplitude is shrinking. And here's the maximum shrink point. And as I increase on time, then it's going to start growing again, like this. Okay? And I'm going to decrease, decreasing, I'm decreasing, I'm decreasing, and as I'm decreasing, now it's going to start growing as I'm decreasing. See, and I'm decreasing, and then it starts shrinking. So just be aware that there's these little points that you can experiment in, like I'm decreasing on time. If I'm decreasing the on time, why is the amplitude growing? Okay, this is the minimum amplitude, this is a low amplitude one, and as I'm decreasing on time, I got a higher voltage amplitude. Yet the current dropped. Okay, and we can see right here 0.20 millivolts, and if I increase on time, into these regular zones here. Let's see. Okay, that's showing 2.6 millivolt DC. Now what I'm going to do is decrease on time, which obviously the power is dropping and the amplitude is dropping. Okay, it's down to 2.1 millivolts. I'm decreasing, I'm decreasing, I'm decreasing, and see, amplitude is decreased, but now amplitude is increasing as the current is decreasing. Okay, I'm going to go back to here. This is decreasing on time, but then we're getting that point right there. See, if I just swing it back and forth, this little point is a higher amplitude. Now I'm back to decreasing the amplitude, but the current increased. Okay, I'm increasing on time. Now here's the peak point. Okay, if I just keep increasing on time, obviously we're going to have a climb. Okay, now I'm decreasing, 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 decreasing. See, 19, 1.9, I'm decreasing, and then it just jumped back up to 2.0. So what I'm able to do is get a higher amplitude for a drop in current, which is following the same type of pattern as the negative resistance zone in some of the transistors. In that little nonlinear zone that doesn't seem to correlate with typical Ohm's law prediction, is that I have a higher amplitude for lower current in that little region right there. Okay, and right there I'm increasing amplitude. See, here's its increase. Now I'm decreasing on time, 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 decreasing, but at that point where that current drops to 1.9, this amplitude is actually at the peak of that little nonlinear zone right there. Okay, 2.1 millivolts. Now the voltage that I'm reading is across a shunt on a fluke scope, but you're looking at the Tektronix waveform. I'm decreasing on time. I'm decreasing on time. Okay, now the shunt reading is 2.1 millivolts. 2.0. Okay, 2.0. Still 2.0. 1.9. See, the current dropped while I'm at this, while the amplitude is actually increasing. So as the voltage across what's happening increases, the current is actually dropping. Okay, and if I just keep going in that same direction, the current just increased up to 2.0. And if I just keep decreasing on time, 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 through this whole range, that current is actually growing across that shunt. It's showing 2.1 millivolts, and as I'm decreasing on time, decreasing on time, decreasing on time, it's actually drawing more power, while this is just everything's getting squashed. Now what I'm going to do is I'm going to go in the opposite direction, increasing on time, increasing on time, increasing, 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 and you can see that it grew and now its amplitude is dropping. Okay, but right at this point right here, you can see it's not linear. So anyway, just experiment with those little zones there. Okay, and I'm going to increase, increase, increase. See, now its amplitude is dropping. Increase, increase, and then its amplitude is growing again. Increase, increase. Okay, and then we're just out of the range right there. And so I'm going to decrease, 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 decrease. Amplitude is shrinking, decrease, decrease, and you can see right there it's starting to grow. And right there is right where it's peaking at the growth for as I'm reducing on time, and that correlates with the 1.9 millivolts across the shunt, which is showing as I'm getting an increase in amplitude in the voltage, I'm actually getting a decrease in the current at the exact same time.